In this video, I want to have a look at differentiation of exponential functions. So we know that the derivative of e to the x is just e to the x. It doesn't change. So we can now use this in conjunction with everything else we know about differentiation. So we'll start with a fairly basic example. We've got differentiate y equals x squared minus e to the x. So to differentiate that, we can have y dash equals, we differentiate this bit, which would just give us 2x, minus the derivative of this, which just stays as e to the power of x. So just applying that one little extra rule that we know now in with the things that we already know. If we have questions that instead of just having an x in the power, have a function of x, then this rule comes in handy, and this is straight from your formula sheet. So the derivative will be the derivative of that power multiplied by the original function. So that's still e to the f of x. So this is what the chain rule looks like for exponential functions. So that leads us to our second question, which asks us to differentiate y equals e to the power of 5x minus 1. So the derivative of that, we're going to have the derivative of the power. So the derivative of 5x minus 1 is just 5, multiplied by that original function, so e to the 5x minus 1. Our next one uses that same rule. So we're asked to differentiate y equals minus 8e to the power of minus 3x squared. So to differentiate this, we're going to have the derivative of that power, so minus 3x squared, the derivative of that would be minus 6x. And then we multiply by the original. So we're going to multiply by minus 8e to the minus 3x squared. And simplifying that, 6 8s are 48, so we'd have 48x e to the power of minus 3x squared. Our next question's a bit different. We've got y equals e to the 4x plus 2 all to the power of 3. So in this one, we're going to multiply everything by 3, so bring that power out the front. We've got e to the power of 4x plus 2, so the inside stays the same, but we reduce that power by 1. And then we're going to multiply it by the derivative of the inside, which would be 4e to the power of 4x. So simplifying that down, we'd have 12e to the power of 4x outside of e to the power of 4x plus 2 squared. Our next example asks us to differentiate y equals x cubed e to the 2x. So this is going to use the product rule, which I've got here straight from your formula sheet. So our derivative is going to be, if we had uv, we're going to have u times the derivative of v. So our u is that x cubed, and our v is our e to the 2x, so we're going to differentiate that, which would be 2e to the 2x, plus, and then we're going to have v, so our e to the power of 2x, multiplied by the derivative of that first one, which would be 3x squared. So simplifying that down, we'd have 2x cubed e to the 2x plus 3x squared e to the 2x. And our last example asks us to differentiate e to the x over 1 minus x squared. So that's going to use the quotient rule, which I've got written over here. Now this one I am going to do the working out separately, so our u would be e to the x, which means that du dx is just e to the x because the derivative doesn't change. Our v would be 1 minus x squared, which means dv dx would be minus 2x. So if we put all of that into our formula, then our derivative is going to be v times du dx, so that's this times this, so we'd have e to the x outside of 1 minus x squared, minus, and we've got u times dv dx, so u times dv dx, so we'd have e to the x times minus 2x, and that's all over v squared, which is our 1 minus x squared, all squared. Now simplifying this top bit here, we're going to have e to the x outside of 1 minus x squared plus 2x e to the x over 1 minus x squared, and we'll just make it a little bit easier. Let's just pull out that common factor of e to the x in this one. So we can have e to the x outside of, here we'd have that 1 minus x squared, and we've got this plus 2x here, all over 1 minus x squared squared. Now we could have pulled out a common factor up here as well. If we wanted to pull out a common factor, it would have been x squared e to the 2x. And that here would have left us with 2x. And we would have had 2x plus 3 in that bracket there. Both of those answers are correct. It just depends whether you want to factorize or not. All right, so that's how we can incorporate exponential functions into our regular differentiation rules.